Hello, welcome to this channel. Are you a student struggling with arithmetic progression in mathematics? Or are you preparing for WAEC, NECO, or JAMB? In this video tutorial, I'm going to teach you from scratch how to solve arithmetic progression problems in mathematics, how to find the end term of an arithmetic progression, how to find the arithmetic mean of an arithmetic progression, how to find the sum of an arithmetic progression. By the end of this lesson, you should be able to solve my questions confidently. Just stay tuned. An arithmetic sequence is simply a list of numbers arranged in a definite order. Example is 2, 4, 6, 8, and 10. This type of sequence is called an arithmetic sequence, an arithmetic progression. Why is it called an arithmetic progression? The reason why it is called an arithmetic progression is because it is arranged in a definite order. The difference between terms in this sequence is constant. The difference between 2 and 4 is 2. The difference between 4 and 6 is 2. The difference between 6 and 8 is 2. The difference between 8 and 10 is 2. So we can see that there's a constant difference between the terms, between the numbers. Now, because of the fact that this difference is constant, that's why this type of sequence is referred to as an arithmetic progression. And the difference is represented with the letter D. It is called the common difference of the arithmetic progression. In this instance, the common difference is equal to 2. The end term of an arithmetic progression can be derived with the formula Tn, which represents the end term, is equal to a plus n minus 1 multiplied by t, where a is the first term of the sequence, d is the common difference, n is the number of terms in the sequence. So anytime you come across a question in arithmetic progression where you are asked to look for the nth term of a sequence, this formula you should always recall this formula. This formula should come to mind. Tn is equal to a plus n minus 1 multiplied by d. Example, find the 10th term of this sequence, 2, 5, 8, 11. To derive the 10th term of this sequence, firstly, we know that the first term of the sequence, the first number on the sequence, is equal to 2. This is the first term. The common difference is the difference between the terms. So in this case, the difference between 2 and 5 is 3. The difference between 5 and 8 is 3. The difference between 8 and 11 is also 3. And because this value is constant, this is an arithmetic progression or an arithmetic sequence. And this number 3 is the common difference. Therefore, D, which represents the common difference, is equal to 3, is equal to 3. While the number of terms in the sequence, which is represented by the letter n, is equal to 10. The question says we should find the 10th term. Therefore, applying the formula Tn equals to a plus n minus 1d, Tn is T10 is equal to first term, which is 2, plus number of term 10 minus 1 multiplied by d, the common difference, which is 3. Therefore, T10 is equal to 2 plus 10 minus 1 is 9. 9 multiplied by 3 is 27. Therefore, T10 is equal to 2 plus 27, which is equal to 29. Therefore, the 10th term of the arithmetic progression is equal to 29. Arithmetic progression is 18, and the 9th term is 34. Find the first term and the common difference. Solution. So this is how I'm going to solve this problem. The 5th term is equal to a plus n minus 1d. The 5th term is 18, therefore 18 is equal to first term is unknown. 5th term is a number of 10 as 5 minus 1 all over d. Therefore 18 is equal to a plus 4d. I'm going to call this equation 1. The second part of the equation says the 9th term is 34. Therefore, A9 is equal to A plus n minus 1d, where A9 as the 9th term is equal to 34. First term is unknown. Number of term is 9 minus 1d. Therefore, 34 is equal to A plus 8d. I'll call this equation 2. Says find the first term and the common difference. The first term is A, the common difference is D. So we're going to look for A and D. So to get the values of A and D, I'm going to use simultaneous equations. These are simultaneous equations. So I'm going to use elimination method to solve for the values of A and D. So this is equation 1. This is the same thing as A plus 4D is equal to 18, equation 1. A plus 8D is equal to 34, equation 2. So to apply elimination method here, I'm going to subtract equation 1 from equation 2. Subtract 1 from 2. Or rather, subtract 2 from 1. So A minus A is going to be 0. 4D minus 8D is going to be minus 4D. 18 minus 34 is going to be 16 minus 16. Therefore, to get the value of D, I'm going to divide both sides of the equation with minus 4. If I divide both sides with minus 4, the equation becomes minus 4D all over minus 4 is equal to minus 16 over minus 4. Minus 4D will cancel out minus 4. D minus will cancel out minus 4 into 16 is 4, 4 here 1. Therefore, our common difference is 4. To get the value of the first term, I'm going to substitute my common difference into any of the equation above. So if I substitute D into equation 1, A plus 4D is equal to 18, equation 1. Substitute 4 also here. Substitute D, which is equal to 4. or substitute the value of 4 into D. So this becomes A plus 4 multiplied by 4. So I'm going to put 4 in place of D is equal to 18. So A plus 16 is equal to 18. To make A the subject of the formula and to eliminate 16, I'm going to subtract 16 from both sides of the equation. So subtract 16 from both sides. If I do that, the equation becomes A plus 16 equals to 18. A plus 16 minus 16, 18 minus 16. A is equal to 2. Therefore, the values of A is equal to 2 and the value of D is equal to 4. We're asked to find the number of terms in the AP, the number of terms in the arithmetic progression in the sequence. And the number of terms is equal to n. It is not known. We have to look for the number of terms. Now these are the sequence or the terms that are provided in the sequence: 5, 9, 13, and 401. So we don't know the number of terms. We have to look for the number of terms. The first term in the sequence A is equal to 5. The common difference is the difference between 5 and 9, which is 4. The value of the nth term in the sequence is given as 401, 401. So the value of the nth term is 401, but the number of terms in the sequence, we don't know that. We don't know it. So we have to look for it. So we're going to use the formula an is equal to a plus n minus 1 multiplied by common difference. An is equal to the nth term, which is 401, plus the first term, which is 5. N minus 1, n is not known. So this is the same thing as 401 is equal to 5 plus common difference is 4. So 4 multiplied by n is 4n, 4 multiplied by 1 is 4. So this is the same thing as 401 is equal to 5 minus 4 plus 4n. 401 is equal to 5 minus 4 is 1. 1 plus 4n. This is the same thing as 4n is equal to 401 minus 1, where n is equal to 400 all over 4. Therefore, n is equal to 100. So the number of terms in the sequence, which is n, is equal to 100. Asked to insert 4 arithmetic means between 3 and 23. Solution. So this is the sequence. The sequence is 3 to 23. So inside this sequence, there are 4 unknown values. So the question says we should insert the 4 unknown values. So this is a common question that you will come across in arithmetic progression, where you are asked to insert arithmetic mean into a sequence. So to solve this kind of problem, you apply the formula D is equal to last term in the list minus the first term in the list all over n minus 1, where n is the number of terms in the sequence. In this instance, there are 1, 2, 3, 4, 5, 6 terms in the sequence. Therefore, n is equal to 6. So if I apply the formula d, which is the common difference, is equal to the last term in the list is 23 minus the first term in the list, which is 3, all over n minus 1. N is 6, the number of terms in a sequence. Therefore, this is 20 over 5, which is the same thing as 4. Therefore, the common difference between the terms in the sequence is 4. And we know that in arithmetic progression, that common difference is a constant value. So how do we get, or how do we insert the remaining, how do we insert the unknown values into the sequence? To do that, we know that to get the second term in the sequence, all we need to do is add the common difference to the first term. So first term plus common difference, that is common difference A plus, first term A plus common difference D is 3 plus 4, which is 7. Therefore, the second term in the list is 7. The third term in the list is the second term, 7, plus the common difference, which is 4. The third term is going to be 11. The fourth term in the list is 11 plus the common difference, and the value is 15. The fifth term in the list is 15 plus the common difference, which is 19. Therefore, the 4 unknown values in the sequence are 7, or if I rewrite the sequence, the sequence will now be 3, 7, 11, 15, 19, and 23. So if the second term in the sequence is A, therefore means that the first term in the sequence is going to be A minus D. Because if the second term is A, therefore A minus the common difference, which is D, will give us the first term in the sequence. While A plus D, which is the common difference, will give us the third term in the sequence. So let's assume that these are the 3 consecutive terms: A minus D, A, and A plus D. Now, the question says the sum of the 3 terms is equal to 27. Therefore, A minus D plus A plus A plus D is equal to 27. So this is the same thing as A plus A plus A minus D plus D equals to 27, if we collect like terms. So A plus A plus A is 3A, minus D plus D is 0. Therefore, 3A is equal to 27. A, therefore, is equal to 27 over 3, which is equal to 9. So the value of A is equal to 9. So we have the value of A as 9. Therefore, and the question says that the product, so the value of the second term in the sequence is equal to 9. The question also says that the product of the 3 consecutive terms, A minus D multiplied by A plus D, is equal to 504. So if the middle term is 9, this means that 9 minus D multiplied by 9 plus d multiplied by 9 is equal to 504. So if we multiply through, this is going to be 9 times 9, 81. 9 times plus d is plus 9d. 9 times minus d times 9 is minus 9d. Minus d multiplied by plus d is equal to minus d squared. Multiplied by 9 is equal to 504. So this is the same thing as d squared plus 9d minus 9d is 0. So therefore, this is the same thing as this is the same thing as 81 minus d squared. Multiplied by 9 is equal to 504. So we can take away this 9 from here by doing something like this: 81 minus d squared multiplied by 9 all over 9 is equal to 504 all over 9. So to eliminate this 9, to cancel out this 9, we divide both sides of the equation with 9. So 9 will cancel out 9. This becomes 81 minus d squared is equal to 504 divided by 9 is 26. Therefore, this is the same thing as minus d squared is equal to 26 minus 81. So minus d squared is equal to 26 minus 81. So if we multiply 81 from both sides, 81 minus 81 is 0. Minus d squared therefore is equal to 26 minus 81. This is the same thing as minus d squared is equal to minus 25. So minus we cancel out minus, d squared is equal to 25. Therefore d, to eliminate this square, we square root both sides. D therefore is equal to the square root of 25, which is equal to 5. Therefore the value of d is 5. The three consecutive terms are a minus d, a, and a plus d. We know the value of a as 9. We know the common difference d as 5. Therefore, to get the three consecutive terms, 9 minus 5, 9, and 9 plus 5. These are the three terms. So 9 minus 5 is 4. 9 plus 5 is 14. So these are the three terms in the sequence: 4, 9, and 14. The question says the sum of the first n term of an AP is equal to Sn is equal to 2n squared plus 3n. Find the first term. Find the common difference. So how do we go about solving this kind of problem? And the first thing we're going to do, we're going to look for the first term. The solution, first term, so the sum of the first n term is equal to xn is equal to 2n squared plus 3n. So we're asked to look for the first term. So let the first term, so let our n equal to 1, which is the first term. So number of terms in the sequence, 1. So we're looking for the first term in the sequence. And we are assuming that for now, this is the only term in the sequence. Therefore, n is equal to 1. So if we substitute 1 into this equation, xn is equal to 2 multiplied by the square of 1 plus 3 multiplied by 1. So this is the same thing as the square of 1 is 1. 2 times 1 is 2. 3 times 1 is 3. Therefore, the sum of the first term is 5. Now, if the sum of the first term is 5, if the sum of the first term is 5, the first term of the sequence, which is the only term we know, this is the only term, the only number we know in the sequence, it is 5. So we are going to assume that 5 is also the first term of the sequence. So 5 is also the first term of the sequence. So the question says that we should look for the first term. So we have the first term, which is equal to 5. The question also says we should look for the common difference. So how do we find the common difference? We have the first term already. So we have to look for the common difference. Now, to look for the common difference, what we are going to do is to we are going to look for the sum of the second term, or the sum of the first 2 terms in the list. So n is going to be 2. So if we are applying this same formula, 2n squared plus 3n, and we want to look for the second term in the list. The reason why I want to look for the second term in the list is because I'm looking for the common difference. And I know that the common difference is the difference between the first term and the second term. So I already have the first term. So if I'm able to get the second term, then I will now subtract the first term from the second term to get the common difference. So to do that, I'm going to look for the sum of the first 2 terms in the list. Which is the same thing as the second term. So I'm applying the same formula. My n is going to be 2. So 2n squared plus 3n. So if the number of terms in a list is 2, this becomes 2 multiplied by the square of 2 plus 3 multiplied by 2. So this is the same thing as 2 multiplied by square of 2 is 4 plus 3 times 2 is 6. This is the same thing as 8 plus 6, which is 14. Therefore, this is what we have. We have a sequence that is made up of 2 items. The first item is 5. The sum of the first n term is 5. And the sum of the first n term is equal to the first term in the list. The second item is 14. 14 is the sum of the first 2 terms, that's 1, 2. So it means that if I add a certain number to 5, I will get 14, because 14 is the sum of the first 2 terms in the sequence. Okay, so we have the sum of the first term, which is equal to 5. Now, because 5 is the only number, is the first term in the sequence, and it is the only number that we know that is in the sequence for now. So we are going to take it as the first term of the sequence. So A, which is the first term, is also equal to 5. So that answers the first question. The question says we should find the first term of the sequence. So the first term is equal to 5. The second part of the question says we should find the common difference. To get the common difference, we are going to look for the second term in the sequence. So the difference between the first and second term in the sequence is the common difference. So to get the second term, we are still going to apply xn is equal to 2n squared plus 3n, where xn, x2 is equal to 2, n is equal to 2 plus 3n. Therefore, 2 times 4, square of 2 is 4, plus 6. This is equal to 8 plus 6, which is equal to 14. So the sum of the first two terms in the sequence is equal to 14. So if the sum of first term plus the sum of the first two terms in the list or in the sequence is equal to 14. Therefore, if it is equal to 14 and we know that the first term, which is the sum of the sum of the first term in the sequence, we know that it is equal to 5. And this means that the second term in the sequence is going to be 14, which is the sum of the first two terms, minus 5, which is the first term in the list. So this is going to give us 9. So this means that if 5 is the first term in the list, 9 is the second term in the list. Or if 5 is the first term in the sequence, 9 is the second term in the sequence. Because 5 plus 9 is going to give us the sum of the first two terms in the list, which is equal to 14. Therefore, this means that the second term in the sequence is 9. So how do we get the common difference? We know that the common difference is a constant value, a constant increment in the sequence. So it means that the difference between 5 and 9 is supposed to give us the common difference, which is D. And 9 minus 5 is 4. So if 9 minus 5 is 4, it means that 4 is the common difference. Because if you add 4 to 5, you will get 9. If you add 4 to 9, you get 13. That is supposed to be the third term in the list.